is a misconception about how to teach adding and subtracting positive and negative integers in a way that makes sense to students. Some teachers use expressions as owning when the quality is positive and owing when the quantity is negative. This misconception lies with the improper understanding of negative numbers. What we are going to explore in this video is methods and examples of teaching addition and subtraction of positive and negative integers in ways that students may be able to understand the concept better. For example, when students see a question like this, -4 plus an unknown integer equals -10, they may be confused. Here's a suggestion on how to help them gain a better understanding. The first strategy is review what a negative number is. We can start by making a visual, such as a number line. On this number line, you show both positive and negative integers. We would explain to the students that all positive numbers go to the right of 0 and all negative numbers are placed to the left of 0 on the number line. We could get students to compare numbers using the greater than, less than, or equal to symbols such as this. The values of 5 and 7, getting them to place the proper symbols. Students can then be asked to place these values on the number line to give them a stronger visual and a stronger understanding. Students should also be able to understand that when you have two positive integers, they all move to the right. When students have two negative integers, they all move to the left. When students have a positive and a negative integer, they move over the number 0. We can also give students the strategy of applying a symbol for the positive and negative integers if they don't wish to apply a number line to every question. For example, I'm going to apply circles to positives and squares to negatives. They're made of opposites is going to be equal to 0. For example, 3 plus 4. We know that 3 will have 3 circles because it's a positive integer, and 4 will have 4 circles because it's a positive integer. Since they are the same symbol, we can just count 1, 2, 3, 4, 5, 6, 7. If we have two negative integers, such as -6 and -3, we know that those will be squares. So we can draw 6 little squares and 3 little squares. And again, since they are the same symbol, they can just be simply added. -1, -2, -3, -4, -5, -6, -7, -8, -9. The trick is when we have both positive and negative integers, such as 3 minus 2. We know that the negative applies to the value of 2. So we have 3 circles and 2 squares. We cross off a pair of circles and squares, which are equal to 0. This is what's left over, which means our answer is +1. Although we did not have integer tiles, it would be smart for students who are kinesthetic learners and visual learners to give them a set of integer tiles to do the same idea. One thing to mention and remind the students of is that if there's no sign in front of the integer, such as in this question, it means that the integer is positive. The third strategy that we have is to teach them the set of rules. The first rule: if the signs are the same, then add the numbers and keep the original sign. For example, -42 minus 15 is equal to, we know a negative value because both integers in the beginning of the question are negative. If the signs are different, then subtract. The big number minus the little number. Keep the sign of the big number. For instance, 12 minus 23 equals a negative value because the larger integer belongs to a negative sign. negative 17 plus 92, we know will be equal to a positive value because a positive applies to the 92. The fourth strategy we can do is giving students word problems that they can relate to, or realistic problems. For example, Charlie lives in Saskatoon, Saskatchewan. The table shows the temperature changes in Saskatoon over a 3-hour time period. In the chart it says from 6 a.m. to 7 a.m. the change in temperature was negative 2.5 degrees Celsius. From 7 a.m. to 8 a.m. it was negative 3.5 degrees Celsius. From 8 a.m. to 9 a.m. it was positive 2.0 degrees Celsius. Charlie noticed the temperature was minus 3.5 degrees Celsius at 6 a.m. What is the temperature at 9 a.m.? There are 3 strategies we can teach the students to answer this question. The first one is you can make a number line. The second one is you can draw symbols. And the third way is you can create an equation. Since we have practiced the other 2 strategies, we are going to make an equation. So we know that at 6 a.m. the temperature was negative 3.5 degrees Celsius. The change in temperature from 6 a.m. to 7 a.m. was negative 2.5. From 7 a.m. to 8 a.m. was negative 3.5. And from 8 a.m. to 9 a.m. it was positive 2 degrees Celsius. We can teach the students to simply add the values. So we know that by adding the values, both positive and negative, the temperature will be minus 7.5 degrees Celsius at 9 a.m. In conclusion, these strategies are not the only way to teach this math misconception, but they are strategies that can help students to understand the concept better. To answer my initial question, when some teachers use owning when the quantity is positive and owing when the quantity is negative, I don't think that this strategy is wrong, but to avoid initial confusion that leads to this misconception, we should teach students basic strategies such as the number line, symbols, using number tiles first, and then move to this strategy of owing and owning if needed. This conception fits into the grade 6 curriculum. The outcome is demonstrates understanding of integers concretely, pictorially, and symbolically. The indicator suggests that students will be able to compare 2 integers and describe their relationship symbolically, represent integers pictorially, physically, and concretely, and extend a given number line by adding numbers less than 0 and explain the pattern of each side of the number line. This math misconception also fits into the grade 7 curriculum. The outcome is demonstrates an understanding of addition and subtraction of integers concretely, pictorially, and symbolically. Suggestions of indicators are using the use of integer tiles, illustrating a number line, adding and subtracting using concrete items or pictorials, and solving problems involving addition and subtraction of integers. This is my math misconception. I hope you enjoy it, Egan.